Hey, greetings logic students. It's me again, and we're going to get grooving to the second to last section, lesson 16, rules of replacement. And well, sorry for the long delay. I was having technical difficulties, and so here we go. All right, so let me pause it. Well. Yeah, let's get go. Let's get go. I'm going to start. I'm going to do two problems from the section, or three problems. Okay, so here we go. But what I want you to do, you see all the solutions over there, and I don't want to show you the solutions. All right, so these you need to take a look at these. So I'm not going to go through each one individually. Okay, you could read this section. I like this one. It seems like some pirate or something. Props to Jim Nance and Douglas Wilson, the logic book that I'm using, so I want to give kudos to them. They're the experts. So, mathematical term, in math we use commutative property, and associative property, and distributive property. Okay, but in logic here we're just using commutation, association, and distribution. Okay, associate, like your friends, you associate with your friends. This is where the parentheses, the grouping changes. So it went from this group to that group. Okay, communication, or commutation here, the order switches. So it went PQ to QP. Okay, or with the and here, or a but, it switches, same thing. Okay, we've got our equivalency symbols all in between. So it's saying this is equivalent to that. This is equivalent to that. Okay, so that's the point of rules of replacement. We can take this and we can replace it with that, the whole quantity. Or we could take this and replace it with this whole thing. Okay, distribution's kind of cool. I like this one. It's so fundamental mathematics. So this is kind of neat. It's like it distributes to both terms, but it preserves the and here in the middle. So it's the P and, so with the or in between. Okay, so pay attention to the order. It's super important. If there was an or here, the or goes twice and the and is once. Here the and is twice and the or is once. Super, super important. Okay, so let's get started. Okay. Okay, so I'm going to work number 12 in your book, number 16, number 17. Okay, so I like to have all the rules in front of me. So kind of showing you, I got my things here. I've got my rules of inference over here, and I've got my rules of replacement over here. So I'm kind of looking at those, and I'm hunting and finding, trying to find the logical flow. But sometimes I'm going, what can I use next? These are kind of nice because the work is kind of done for you. All we're doing here is the hardest part's already done. We're just finding the rule that fits, so to speak. All right. So I look at this one and go, how did this one change? How did this one go from here to there? So really, if I look at this line and this line, not much changed. The only thing that changed was these two swapped. So that's going to use line 1, and we're going to use commutation. All right. If you look at the abbreviation of association, all right. Obviously, you want to kind of you use ASSOC for obvious reasons. Okay. Let's see, number 4. All right. So based off that, then if you look at the order, they went to this. How in the world did we go here? Okay, and so we might have to do a little exploration. Oh, it sounds like that one. Oh wait, there it is. So if you look at exportation, okay, if you look at exportation here, it's got it's got this, and then it says you can change it to that. That is exactly what we have here on our work. We have this, and then it goes to that. Yes, the letters are capital here, but if you see, we've got this, we've got this line, and then we immediately go to that line. Okay, so that's going to use line 3. Okay, we're using this line, so we got a list. If we use more than one line, we use a comma and we list all the ones we use. And then this one is exportation, so we just call it EXP. All right. Then finally, this last one here, it's going to use both of these. And this is probably one of my favorite as a geometry teacher. It's called the transitive property in geometry. But this is probably one of the most used. Well, I love it. It's so great. But you kind of take a look at this. It's going to use lines 2 and line 4 here. So we're going to use line 2 and line 4. Okay. But actually, I'm going to use it in the order of lines 4 and lines 2 first. So line 4 is first, and then line 2. My end goal, again, is QS. So I've got to get Q first, and then S. So watch what happens here. All right. If I can think of this like, if I think ABC's here. If A, then this whole thing, then B. If B, then this whole thing C. Okay? A, B, B, C, therefore A, C. Let me do that again. A, B, B, C, therefore A, C. Okay? Let me go back to hypothetical syllogism. PQ, QR, therefore PR. Okay? That's what we just did. So that's going to be HS. Okay? Alright, let me set up the next one. Alright, so I decided to skip number 16. I mean, it's there, and I'll probably show you the answers here in a moment. But I want to go to 17. Okay, I want to pretend for a moment that you don't have the answers. Okay, I mean, what I mean by that is you don't have all the steps here. Let's see if we can prove this together and doing the steps. Okay, all right. I will give how many steps first. Okay, so pretend that this were our problem. Okay, don't look at the book yet, but pretend this were a problem. And all I knew was this. I want to prove this, given these two lines. I want to prove this. Now I've got to go, and this is going to take a total of 9 steps. Okay, so I'm gonna put those down there. Okay, so again, I'm going to pretend for a moment that all you know is that this is total number 9 steps. Okay, you don't know this, so don't look at the book yet. All right, now the book, I just want you to get this, but we're going to pretend that we're trying to prove this. Okay, we know this last step. Okay, this is kind of interesting here because I think you do. I think you can see where this last step is going to come from. Okay, it's going to come from here. Okay, it's going to come from here, and we want QR. Okay, but we want a conditional if Q then R. But we have, let's block this off a moment and see that we have QVR. Okay. Well, the previous step is going to be, let's look at implication, all right? In fact, there's 2. So material implication, all right, over here. And you see that if P then Q is equivalent to not P or Q. Ooh, look what we have here. Not P or Q. I know it's Q and R here, but not P or Q will be Q if Q then R. So this is going to be, this last step is going to involve implication. Now I don't always start at the back, but as a geometry teacher, sometimes when I'm doing proofs, I encourage my students to go, look at the very last step. Look at the last one. All right, you already know what the end answer is going to be because you're trying to prove this, okay? And, you know, maybe think back one step, and that might jog your memory and go, where can I go forward now? Now my goal is to, obviously we know that we want to get this by itself, but the question always is how? How do I get this by itself? Well, I can see Q and R by itself right here if I can use implication. So my goal now is to get this to be by itself. Okay, So I'm going to ignore line 1 for a moment, okay, because I want to work on line 2, okay. Why is that important? Because I've got to get a P out. I've got to get rid of this P in this sentence here. But in order to do that, I'm going to have to use this one, okay? So ignore line 1 for a moment and just focus on line 2. This one begs to be distributed. I mean, look at it. It's like, I want to be distributed. Well, then distribute it. Okay? So then we think, okay, I want to get this, really I want to get rid of this. My goal is I want to get this because I need a P. I need to get a P here, okay? Well, I'm going to swap the order of these two, okay? And hopefully you can see what I do next. Okay, so I just swapped the order of these two, okay? So no big deal, just swap those. This is like AB, and this is now BA, all right? Now, what's next, okay? This one's going to be tricky because it's like I'm going to be able to get rid of this whole last part over here. Okay, watch what I did. Okay, I use line 4, simplification. Look up here, simplification. P and Q, therefore P. All right. So now this one should be pretty easy. This one's like this is going to simply become not P. Okay. This one's your tautology, okay? Tautology, okay? All right. Now what do we go? Where do we go from there? Remember in the beginning that I want to get these two together. I bet there's a rule that allows me to group these two and not have these two grouped. Right? A grouping. What's grouping? Okay, so there's associative right there. We group this with that. Okay, so now we have this, and then we have this. Okay, how does that help us? Often when I have a not P, I look at my ones and go, okay, how does not P help me? And in fact, I would look at my rules of inference and go, where's not P at? And if I go back to my rules of inference here and go not P, ooh, look at not P right there. P or Q, not P, therefore Q. Okay. P or Q, not P, therefore Q. P or Q, not P, therefore Q. Okay, again. P or Q, not P, therefore Q. And that was disjunctive syllogism. Okay, finally, which we inferred from the very beginning, okay, in order to get this, we needed to get these two together, and from implication here, going back to implication, alright, right here, we want this, but we had this, okay, so, and that's the good thing about equivalence, is you can go backwards or forwards. If you have this, you can go that way. If you have this, you can go that way. That's the great thing, and mathematics same way. If A equals B, then B equals A. You can go either direction, it doesn't matter. So, we have this, so we get this, okay? So, and booyah, there we are done. So for homework, you're just naming the steps. You're just naming the steps. They're giving you all these, but you're naming the steps. Now, obviously, the goal is to do like what we did. I don't think I will give you a 9-stepper, but certainly a 5, 6, or 7-stepper, okay? But, so your goal for homework is just to name the steps. So go through the exercise and name all the steps that are used. I, again, totally recommend writing them off on a separate sheet of paper so they have them in front of you, because there's a lot of rules there. It's like playing a puzzle game there. Okay, so I don't have anything else. May the good Lord bless and keep you, and y'all have a great and wonderful day. Okay, stay safe out there. All right.